Hello everyone, welcome back. Lesson number 24 for BC Calculus. We're talking in this video about the derivative of exponential functions. It is going to be one of the shortest videos that I've made for you guys because the derivative of an exponential function is so straightforward. Alright, so the derivative of e to any function is going to be equal to e to that function. So you just plop it right back down. You don't change it, you leave it alone, and then you're going to multiply by the derivative of the exponent of the function. That is it, ladies and gentlemen. That's all you do. It's actually so straightforward. So when you're looking at this derivative of e to the 2x, then your derivative is going to be e to the 2x, and then you're going to multiply by 2. Done. So 2e to the 2x. Awesome. Example number 3. If I ask you guys to find the derivative of this one, k prime of x, you're going to write e to the tangent of x times the derivative of tangent, which is secant squared. Done. That's all it is. The most important, maybe the most challenging thing here is to actually find the derivative of the exponent. I just want to say really quickly, number 2, remember that e to the 4th is a number. So this derivative is going to be simply j prime of x is simply going to be e to the 4th. Right? Just think about it. If e to the x is a number, so if I ask you guys to find the derivative of 5x, the derivative is 5. It's just the constant, right? Some constant x, the derivative is just that. So some students may think about doing the product rule here. You don't have to do that. You don't have to do that at all. All right, so just want to make sure I clarify with that. Question number 4, we're going to fly through these because they're very straightforward. You leave the number alone. It's just like if I ask you to find the derivative of 4 sine of x. You can leave the 4 alone and just multiply by the derivative of sine. So you're just going to do 4, and then we're going to do e to the 1 minus 2x, and then we're going to multiply by the derivative of this exponent, which is going to give us a negative 2. So this is going to be negative 8 e to the 1 minus 2x. Simple, done, straightforward. If you look at example number 6, it's pi e to the x. Well, that derivative is going to be pi e to the x. So I wanted to say very quickly that this example would be, if I give you guys a function where I have some constant a e to the x, the derivative is going to be a e to the x. Because again, your constant and then the derivative of e to the x is just e to the x. So anytime you guys see some number e to the x, it's just going to be that same number e to the x. It's going to be itself back. And then, you would do this part right here like you would normally do, finding the derivative of x to the 1/2 would be 1 over 2 square root of x. Looking at the bottom problems right here, like example number 7, we just have to remember that we're taking the derivative of an arc sine, and our theta, quote unquote, is going to be e to the x. So when we're taking a derivative, remember that we're going to do our u is going to be e to the x, our du is going to be e to the x, and then our u squared is going to be e to the 2x. So our derivative for this function is going to be 1/2, and then we're going to do 1 over the square root of 1 minus e to the 2x times e to the x. And this is just straightforward arc sine. Remember, the derivative of arc sine is 1 over the square root of 1 minus u squared times the derivative of u. Remember that little formula. And so that's what this is. So if I were to simplify this down a little bit more, I would get that this is e to the x over 2 times the square root of 1 minus e to the 2x. And that's it. That's all you do for that question. For question number 8, we would actually use the quotient rule on this one, right? Or you could rewrite it as x to the negative 2, but why just make it as simple as possible and use the quotient rule, in my opinion, for this particular problem. So when we do the quotient rule for this one, we're going to do u prime of t is going to be equal to your denominator times the derivative of your numerator. That's awesome. Minus your numerator times the derivative of your denominator all over your denominator squared. And you can go ahead and take out some stuff here. I mean, we can look at this and we can take out an x in all of these. And we can factor out an e to the x if we needed to. So, you may see it written a little bit different with this and say, okay, well, e to the x is in the top with x minus 2 all over x cubed. And that's all you do. That's all you do for these kind of questions. And then for question number 9, this is simply a product rule problem. It's a product rule problem, so w prime of t is going to be equal to 2x. The derivative of e to the square root of x is just e to the square root of x times 1 over 2 square roots of x, again, the derivative of our exponent, plus e to the square root of x, times the derivative of 2x, which is going to be equal to times 2. That is it. So straightforward. So I hope you guys are understanding this and getting it, because it is that straightforward. The derivative of e to a function is just e to that same function times the derivative of that function. Implicit is actually, something where we do have to do a little bit more with our work. So let's look at, these two kind of questions here. So I'm asking you guys to find, dy dx of this problem. This is more likely the more challenging stuff, where we have x's and y's. So for this particular problem, the first part here, it's going to be a derivative. We have to find the product rule by using the product rule. So it's going to be first. And so it's going to be x, and then the derivative of e to the y is just e to the y, but then dy dx, plus ey times 1. So that gives us the derivative of that, plus the derivative of 8x is just 8. The derivative of 3y, or negative 3y, is negative 3 dy dx, is equal to 0. Is equal to 0. And you guys are very good with this. You know what we need to do here. So I'm going to have e to the y plus 8 on one side. I'm going to move everything else on the left, or sorry, to the right side from the left, like so. And then you guys can see with this, I'm just going to go ahead and, I would undistribute this, but I think you guys are very intelligent people, so you know what I'm doing here. And I get this is my answer. So e to the y plus 8 all over 3 minus x e to the y. And so that's going to be our answer for question number 10. And then for question number 11, we're going to take the derivative of e to the xy. So this is going to be e to the xy times our derivative of x times y, right? So it's going to be the first times the derivative of the second plus the second times the derivative of the first. So e to the xy is being multiplied by both of these pieces, is equal to e to the 4x times the derivative of 4x, which is 4, minus e to the 5y. So the derivative of e to the 5y is e to the 5y times 5 dy dx. And I wish I could write a little bit smaller, but it is what it is. We're going to go ahead and distribute this on the left side, and there's probably much easier ways to do it, but you know me, I got to do it, what I think is the easiest way to do it, but we're going to go ahead and just make this look a little bit prettier for our part right here. And then, ladies and gentlemen, you guys know what happens after this, right? So I went ahead and took the derivative of these problems, and then everything that has a dy dx I will put to one side. So I'm going to go ahead and move this guy over here. I try to make things as much as everything positive as I can. And I'm going to move this over here. So 4e to the 4x, I'm going to do minus ye to the xy. And then our dy dx finally is going to be equal to, and actually this video is a little bit longer than I thought, but that's okay, because we want to make sure that we're good with our implicit. So it's going to be all of this right here, all over our x e to the xy plus 5 e to the 5th y. So hopefully I didn't make a silly mistake there in our work, but that's the difficulty as it's going to get, is what you see right there. So we're done with this video in less than 9 minutes. I'm good to go, and I'll see you guys in the next video.